Okay, I hope I'm audible to all my students who are attending this particular lecture for the Delhi University Intermediate Microeconomics Part 1 course. In this particular lecture, I'm going to start with the discussion of the 2023 question paper, which has come up at Delhi University for the Intermediate Microeconomics Part 1 course, which all students can currently see on your screens. Okay, so it contains questions based on the concept of consumer theory in particular, followed by producer theory. If I scroll down this particular question paper, okay, students can clearly see that it contains problems from section A as well as problems from section B. So if you look at the format of this particular question paper, it has two sections, section A and section B. Okay, from section A, students need to answer any three questions. And from section B, only two questions need to be answered. So in total, the students need to answer 5 questions for this particular question paper. Okay, so in this particular lecture, I'm going to start with the discussion of problems from section A. So I hope all students attending this lecture can see section A on your screens. We are going to start with the discussion of the first problem in this particular lecture. So let's quickly start with the discussion of the 2023 exam paper for this particular course. So let's look at question 1, part A. Let the utility function of a consumer be given by u of xy equals xy plus x, where x and y are two goods. Part 1 asks us, is the marginal rate of substitution diminished? MRS is nothing but the slope of the indifference curve. Okay, let's find out the MRS for this particular utility function and let's check whether it's diminishing or not. So if I come to the whiteboard, I'm just writing the main heading for completeness. We are looking at Delhi University 2023 question paper for intermediate microeconomics. For the intermediate microeconomics part 1 course. And this is for all those students pursuing economics honors from University of Delhi. So question number 1, part A. We are given the utility function u as a function of x and y is equal to xy plus x. Okay, let's work out the MRS of this. How do I find the MRS? The formula for MRS is marginal utility of good x over marginal utility of good y. Assume that good x is measured on the horizontal axis, good y is measured on the vertical axis. How do I find MUX? That's the partial derivative of the utility function with respect to good x. How do I find MUY? That's the partial derivative of the utility function with respect to y. I've covered all this in detail in my lectures, theoretical lectures on consumer theory. How do I find del u by del x? Partially differentiate the function with respect to x, treating y as a constant. I get y plus 1. How do I find del u by del y? Partially differentiate the utility function with respect to y, treating x as a constant. I just get x. Okay, so del u by del x is y plus 1, del u by del y is x. And if you look at the MRS, it's y plus 1 by x. Now, to check whether it's diminishing or not diminishing, let us increase x and reduce y, because remember, when you move along the indifference curve, you increase good x and you decrease good y. So I can say as x increases and y falls along the indifference curve, what happens to MRS? Students can clearly see as I increase x and as I reduce y. If I increase x, my denominator will increase. If I reduce y, my numerator will decrease. If my numerator is falling and denominator is increasing, the whole fraction falls. That means my MRS falls. So as x increases and y falls along the indifference curve, MRS diminishes. MRS diminishes. That means along the indifference curve, we have shown that the MRS is diminishing because MRS is y plus 1 by x. As x increases, denominator increases. As y falls, numerator falls. When numerator falls and denominator goes up, the whole fraction falls. So MRS falls. So we have used intuitive reasoning for this. Okay, let's come back to the question paper. We are done with part 1. Part 2. Are marginal utilities of both x and y diminishing? How do I check whether the marginal utilities are diminishing or not? So part 2, MUX is what? Del u by del x, which we have already calculated as y plus 1. To check whether MUX is diminishing or not, I further differentiate MUX with respect to x. The derivative of MUX with respect to x is 0 because there is no x here. Similarly, MUY is del u by del y. What is del u by del y? It's x. When I partially differentiate marginal utility of y with respect to x, again with respect to y. When I partially differentiate MUY further with respect to y, what do I get? I get 0 because MUY is x. The derivative of x with respect to y is 0. So I can say that the marginal utilities are not diminished. They would be diminishing if it was less than 0. If del MUX by del x was less than 0, del MUY by del y was less than 0, then I would have said that the marginal utilities are diminishing. So I can say the marginal utilities of x and y are not diminishing. They are not diminishing. Since del MUX by del x is not less than 0 and del MUY by del y is also not less than 0. In fact, they are equal to 0. That means when I partially differentiate MUX with respect to x and when I partially differentiate MUY with respect to y, I get 0. That means I can say that the marginal utility of x is not changing when the consumer increases the consumption of x. And the marginal utility of y also does not change when the consumer increases the consumption of y. So the marginal utilities are constant. They are not diminishing. So I can write, therefore, the marginal utilities are constant. I can write. They are not diminishing. They are constant. Okay, this is the solution for part 2. Let's come back to the question paper. We are done with part A. Part A only had 2 parts, 1 and 2. Let's come to part B. Let Mr. Ramesh have an income of 1000 rupees, which he can spend on 2 goods X and Y. Price of good X is 80 rupees for the first 2 units and then 60 rupees for the subsequent units. Price of good Y is 50 rupees regardless of how many units bought. Write the equation of the budget line and draw it. This is quite easy. Okay. So if I come back to the question, to the whiteboard, question 1, part B. I'm quickly writing first of all what is given to us. Okay. We are given that there are 2 goods, X and Y. Okay. Let me write them clearly. So I can write that there are 2 goods, X and Y. Okay. And we are given that the price, the income of the consumer, first of all, income of the consumer is 1000 rupees. Okay. We are given that price of good X is rupees 80 for X equal to first unit and second unit. And we are given that it's equal to rupees 60 for X greater than 2 units. That means for the first unit and the second unit, the price is 80. But for X taking a value greater than 2, the price of X is 60 rupees. Price of good Y is given to us as rupees 50, regardless of the units. Okay. So how do I find the equation of the budget line? I can write equation of the budget line is so for the first two units, the consumer is going to pay 80 rupees for good X. Okay. The consumer is going to pay 60 rupees for units of good X in excess of 2 units. That means when X is greater than 2, the consumer is going to pay 60 rupees, and for the first 2 units, the consumer is going to pay 80 rupees. For good Y, the consumer will pay 50 rupees for any unit of Y, irrespective of the units, equal to the income of the consumer 1000. So I can write this is the expenditure on first 2 units of good X, because the first 2 units of good X are bought at a price of 80 rupees. This is the expenditure on good X consumed in excess of 2 units. Because for consumption of good X in excess of 2 units, the consumer pays a price of 60 rupees. This is expenditure on good Y. And this is the income of the consumer. Okay, so if I solve this now, for which I am erasing the initial part. So 80 times to 160 plus, if I open up the bracket, 60x minus 60 times 2 is 120 is plus 50y. Let me also write plus 50y equals 1000. See, 80 into 2 is 160, 60x minus 120 plus 50y equals 1000, which implies I have 60x plus 50y. I write them together. And 160 minus 120 is 40 equals 1000. So this implies 60x plus 50y equals 960. 60x plus 50y is equal to 960. Okay, so hoping students have understood this. So if you plot the equation of the budget line, how is it going to look like? So let's look at the diagram. So I can write, first of all, this is the equation of the budget line. Okay, and if I draw a diagram, this is good X, this is good Y. Okay, and you can clearly see that for the first 2 units, the consumer pays a price of good X, which is 80 rupees. For good Y, it's 50. So my price ratio is 80 by 50. That means till X equal to 2, slope of the budget line is minus Px by Py, which is minus 80 by 50, which is minus 1.6. But after X equal to 2, slope of the budget line will be again minus Px by Py. The price you pay after X equal to 2 is 60. Or 50. So how much is 6 by 5? That's minus 1 point. That means in absolute terms, the slope is falling. The line will become flatter. So my budget line is going to look like this. Till 2, it's going to be steeper. Till 2, it's going to be steeper. And after 2, it's going to be flatter. So somewhat like this. Okay. So if it's not looking flatter, let me try and make it look flatter, a bit flatter. So although it would continue like this, but it would be flatter than this. So somewhat like this. So the slope here will be negative 1.2. The slope here is going to be negative 1.6. So this is my budget line. The black portion, the black solid portion, and the red portion. The red portion, I can draw it clearly. This is the red portion. So my budget line is AOB. Budget line is AOB. Okay, so hoping students have understood how we have got this. Okay, so this is my budget line, and this is my complete solution for part B. Now let's move forward to part C. So if I come back to the question paper, find the equation of the price offer curve, okay, and the demand curve for the following utility function. So we are given u equals min of 3x comma 2y. All students can see that this is the case of perfect complements. For a min function, it's always perfect complements, and the indifference curves for perfect complements are all L-shaped. Income of the consumer is M, Px denotes the price of good X, Py denotes the price of good Y. We need to draw the income of the price offer curve and the demand curve. Remember, the price offer curve gives combination of two goods, the optimum combination of two goods at different set of prices. And from the price offer curve, we derive the demand curve. Students can find this in my lectures on demand theory. So if I come back to the whiteboard, question 1 part C, we are given that the utility function is min of 3x comma 2y. Therefore, good X and good Y are perfect complements. Good X and good Y are perfect complements. They are consumed in a fixed ratio, which implies that the indifference curves are L-shaped. Where will the kink occur? In case of perfect complements, in this case, at the kink, I can write 3x and 2y are exactly equal. So I can say that x is equal to 2y by at the kink. This is my kink condition. And this is the equation of the price offer. Equation of the price offer curve. If I draw a diagram to help students visualize this, you can clearly see that this is good X, this is good Y. Okay, the ICs are L-shaped and the kinks occur at the following points. So I can say at the kink points will be what? If I take Y as 1, X will be 2 by 3. If I take Y as 3, let's say, then X will take the value 2 and so on. So if X takes the value 1, if Y takes the value 1, let me correct myself. Y takes the value 1, Y takes the value 2, Y takes the value 3. When Y takes the value 2, by the way, students, what will X take the value? 4 by 3. So when y takes the value 1, x takes the value 2 by 3. So if let's say this is 1, this is 2, this is 3, where will 2 by 3 lie? 2 by 3 is how much? 2 by 3. So I am drawing a rough sketch. 2 by 3 is 0.67. So 0.67 will be somewhere here. So this is 1 point. One indifference curve, I see 0. Another indifference curve when when y takes the value 2, x takes the value 4 by 3. How much is 4 by 3? 1.33. So this is another kink. I see 1. And when y takes the value 3, x takes the value 2. It is blue indifference curve. I see 2. I can stretch it further, I mean. Obviously, there is lack of space, so I can't. But I can stretch the arm. So see, this is the kink 2 by 3, comma 1. This is the kink 4 by 3, comma 2. The blue one is the kink 2, comma 3. And if I join all these with the origin, this is my price offer. On this price offer curve, you can clearly see that x is equal to 2y by. Okay, so hoping students have understood this. And when I can say when my price offer curve is when my budget line changes because of price changes. Okay, so if I also show a diagram with the budget lines, it's gonna look like this. So this is one budget line, AB. And since we are talking about perfect complements, the indifference curve is like this. When price changes from AB, suppose I can say, suppose price of good X falls. Budget line will shift out, it will become flatter. It will move from AB to AP1. I am going to consume here. I cannot disturb the ratio, okay? This is IC1. When price further falls from AB1 to AB2, I will consume somewhere here. This is IC2. So see, my price offer curve is again a straight line through the origin. This is my price offer. So remember from my lectures on demand theory, remember a price offer curve captures, I can recall for all students, a price offer curve captures set of optimum combinations of X and Y when price of one of the good changes. When the price of one of the good changes, while the price of other good and income is constant. So price of a curve is going to capture locus of all, or I can say set of all possible combinations of good X and good Y when price of the other good and income is constant. Price of one of the good changes, price of the other good and income is constant. So this is the price of a curve for perfect complements. Okay, and remember the demand curve. I can also find the optimum combination, optimal bundles, X star and Y star. How do I do that? If I erase all this off, so this is my kink condition. Okay, If I put this in the budget line, putting this in the budget line, what is the equation of the budget line? XPX plus YPY equal to M, where M denotes the income, PX and PY are the prices. This implies instead of X, I can write 2Y by 3. So 2Y by 3 times PX plus YPY is equal to M. I can take Y common. So inside the bracket, I get 2px by 3 plus py equal to m. So this implies y times, I can take 3 as the LCM. So I get 2px plus 3py equal to m. So my y comes out as, this 3 gets multiplied with m here. So 3m over 2px plus 3py. This is my y star, optimum y in equilibrium. What will x star be? X star will be 2y star by 3, which is 2 by 3 times, what is y star? 3m over 2px plus 3py. 3 and 3 cancel out. My x star comes out as 2m over 2px plus 3py. Okay, so this gives me the demand curve. I can write demand equation for good x. And you can see that x and px are inversely related. So if I plot the demand curve, it looks like this. X, price of good x, if I plot it, it looks like this. This is my demand curve for good x in case of perfect complements. Okay, so when you plot this, basically m and py will take fixed values. When you plot this, m and py is going to take fixed values. So when you plot the relationship between x and px, that's inverse. Inverse means my demand curve is downward sloping. So I can write this is my demand. So since the values of m and py were not given to us in the question, we were just given general values. We have to just draw a rough sketch. So my price of a curve is a straight line, upward sloping straight line passing through the origin and passing through the kinks, where the kink is given by this condition, x equals to y by 3, and my demand curve is a normal downward sloping curve for good x. Okay, coming back to the question paper, let's look at part D. Draw the indifference maps for the following utility functions and also indicate the preference direction. So u of xy equals x. This is quite easy. Recall from my lectures on utility theory. We are given that utility from x and y is just equal to x. When I say that utility from x and y is just equal to x, it means that for this consumer, y is a neutral good. For this consumer, y is a neutral good, which neither gives satisfaction nor dissatisfaction, nor gives dissatisfaction. Remember from my lectures on utility theory, neutral goods are those goods which neither give you satisfaction nor dissatisfaction. So if I draw an indifference map for this consumer, all she cares about is good x. So my indifference curves are going to be vertical. And my direction of preference is going to be in the east direction. So higher indifference curves are going to be in the east direction. This is I0, this is I1, this is I2. Okay, so my preference is in the east direction. This is my indifference. Okay, so in this case, I can also write that x is a good and y is a neutral. Whether you increase y or decrease y, you are on the same indifference, because it doesn't matter. Y is a neutral for you. This was part 1. Part 2, if I come back to the question paper, u of xy is minus x minus y. It means x and y both are bad because they are both giving you dissatisfaction. As you increase x and as you increase y, the utility is falling as given by the minus signs. So if I come back to the whiteboard, I can write for question 1, part D, part 2, we are given that the utility function is minus x minus y, which I can write as minus of x plus y. So for this consumer, good x and good y, x and y, let me write x and y are bad. For this consumer, x and y are both bad. And how do I plot x plus y? That's perfect substitutes. So I can just draw a straight line. This is x, this is y. X is also a bad, y is also a bad. And how do I plot x plus y like this? It's a downward sloping straight line. This is my indifference curve. And because both of them are bad, my preference is in the south-west direction. My higher indifference curve will be in this direction. I'm going south and I'm going west. A higher indifference curve further is going to be in this direction. So this direction is the southwest direction we are going. Okay, so hoping students have understood this. So with this, we are done with complete discussion of problem number 1. This is where I stop in this particular lecture. The objective was to look at the first problem for the Delhi University 2023 question paper for the intermediate microeconomics part 1 course. Question 1 had 4 parts A, B, C, and D. We have solved all these parts in this lecture. In the next lecture, I'm going to solve problem number 2. So I stop in this particular lecture. I hope students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.